Hi there. This video is a step-by-step tutorial for the 617 Snell's Law Lab. This version is alternate assessment. It is not exactly the same as the assessment within the lesson, but we hope that you choose this option as it is a little more straightforward than the one in the lesson. So the purpose of this activity is to determine the index of refraction of unknown stolen materials, identify each material to determine who stole the diamonds. So our little crime story here is that we have these three potential criminals, and one of them has stolen some diamonds. Within our scenario, we have some case files. I'm going to scroll down to those. So each potential criminal, has a case file with two trials where basically the material they've stolen has been tested with a light to see how the light is bending through that mystery material. What we would like you to do is read over the Snell's Law information in lessons 15 and 16 first to become familiar with how light is bending into a new material. Once you're familiar with that, you will record the angles that are given within the simulation or the data screenshots. So let's go back up to the table here. You'll be collecting data for angle 1 and 2 from the evidence files, and then you'll be calculating N2. And I'll show you that equation in a moment. After you've calculated your N2 values, you'll need to go to the index table to identify what your mystery material is. Now, of course, we're doing two trials per potential criminal, so it should be the case that trial 1 and 2 are similar, and you're identifying one mystery material for that person. Trials 3 and 4 should be similar, as well as 5 and 6. So we're basically running a test twice on each individual. So let's look at the equation. And actually, before we look at the equation, let's look at the graphic a little more here. I'm going to zoom in a little bit. And what we want to identify is an incident angle and a refracting angle. The incident angle is aimed and measured from the light itself to the normal. So if I were to make an arc from this vertical to the ray, that would be my incident angle, and the simulation gives us that information right here. I'd be recording this value. It's basically the angle I'm aiming at. Now, due to the fact that this new material is more optically dense than the air that this experiment is being held in, the light will bend, and it will bend by a particular amount. So notice this ray of light does not continue on straight. Instead, it is a much smaller angle now. And we can see that refracted angle, which is our angle 2 of 26.81. So that would be the angle from this normal or this vertical to the ray of light. Those values will get recorded here. Angle 1 is the angle of incidence. Angle 2 is the angle of refraction. Once you have both of those, and the fact that this experiment was held in a room with air, we have an index value of 1. And the only thing we're missing is the refracting materials index. So here's our equation. N1 sine of angle 1 equals N2 sine of angle 2. I know N1. It will always be 1 because this experiment was held in a room with air. Angle 1, something you recorded from the table. And angle 2. The only unknown we have here is N2. So you'll want to solve for N2. There will be an additional video going over the algebra and the trig functions if you feel that is an area you need to practice a bit more. But if you're comfortable, you'll simply continue on with calculating N2. And you'll repeat that process for every trial. Once you've identified the mystery materials as listed in this index chart, you'll be able to answer the questions listed as well as draw your conclusion. Hopefully this is a helpful tool in getting you ready to complete this assignment, and if you do have questions, please reach out to your teacher.